Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a real-world crowd sale that can be used to raise funds in an ICO on the Ethereum main network. In the last video, we turned the crowd sale into a minted crowd sale where tokens were minted after purchases. So check out that last video if you haven't already, and be sure to subscribe to the channel to see the next videos in this playlist whenever they come out. This episode is presented by QuickNode, the fastest and easiest way to run your own Ethereum node. QuickNode lets you run a personal cloud-based Ethereum node in a flash without having to download any blockchain data or keep it in sync. Sign up at quicknode.io today to start running your own Ethereum node in no time. In this video, we're going to turn this crowd sale into a capped crowd sale, which means we're going to use a hard cap to limit the amount of funds that we're going to raise in the public phase. So essentially, once we've raised a certain amount of Ether, we won't accept any more investor contributions to this crowd sale. Also, what we're going to do is hand roll some logic that only accepts a minimum contribution total from a single investor. For example, we don't want an investor to contribute a really small amount to this crowd sale. We want kind of a minimum threshold. And we also want to do that on a total basis, not a per transaction basis. And I'll show you how to do all that in this episode. So let's go to our terminal and start Ganache. This will be the in-memory local blockchain. And let's go ahead and run our tests. All right, they're passing. So let's go ahead and head to this test file and write some tests so that we can implement this behavior. Let's go to Dapp token crowd sale. All right, so here's the testing file that we were using that we kind of left off with. So what I want to do is test that this crowd sale actually has, a cap imposed upon it. And so I'm going to write the test first, I think. Let's go ahead and do that. So basically, let's say, below minted crowd sale, we'll just check that it's also a capped crowd sale. Let's say describe capped crowd sale. And I'll say async function. And I'll say let's say it has the correct hard cap. And here, I'll also pass this an async function. All right. And let's say const cap is equal to, we'll set up some, we've been kind of configuring the variables for our deployment and our test suite inside of this before each block. So we'll go ahead and do that in a second. But I'll say const cap is equal to await, this crowd sale cap. All right, this is actually what we're going to implement here in a moment. And I'll say cap should be big number. This is what we did earlier. Let's see here. Should be big number right here, like when we track the rate. That's coming from this chai big number. Should be big number, and we'll say equal. And we'll say this dot cap, which we're about to implement in this before each block. So that's what I'm going to do. Let's set a hard cap of this amount. Let's say we're only going to let's say we're going to only raise 100 Ether in this crowd sale. So we'll say this dot cap equals Ether, which is, this helper that we rolled earlier in the last episodes. We'll say 100. So we're only going to raise 100 Ether in this particular crowd sale. All right. Now, I haven't implemented this yet in the smart contract for the crowd sales, so this test is going to fail. But let's go ahead and run it. All right. Looks like it's passing. That's because I ran the test for the token. Pardon me. So whenever I demonstrated the test passing initially, I forgot to do that for the crowd sale. It's actually the token. A bit misleading, so sorry about that. And so yeah, this is failing, which we expect. So this .crowdsale.cap is not a function. So let's implement the cap on this crowd sale. Let's take a look at the capped crowd sale that's provided by OpenZeppelin Solidity. We'll say capped crowd sale. Let's kind of see, what's going on inside here. So a capped crowd sale is a crowd sale, which we already have implemented in our smart contract. And it's going to expose this public value. It's going to be a getter function for a cap. So this is going to, give us we're going to require a new argument of a cap whenever we pass this into our constructor, which we'll implement here in a moment. And it's going to have, some logic that says, is the cap reached? So the way raised is the amount in the crowd sale. Let's say crowd sale. Way raised right here is what we're keeping track of in the crowd sale, and that's getting incremented every time we purchase tokens, right? In this buy tokens function, way raised is getting incremented. So basically, the cap reached will return true if the way raised has met the cap or exceeded it. And if you go back to this buy tokens function, we see this pre-validate purchase, right? We want to say this function is basically saying we want to validate that you can make a token purchase, right? We're going to stop execution if you're not valid after this function is called. So we override pre-validated purchase by passing in the beneficiary, the address that wants to buy tokens, and the way amount. And it's going to call super on pre-validate purchase, so whatever's been implemented before is going to get called first. But then here, we want to say, way raised, add this way amount, and if that is still less than or equal to the hard cap, then we'll consider this a valid purchase. But if it's not, we'll revert this transaction because we don't want to exceed the hard cap. So basically, if our hard cap is going to be 100 ether, and let's say we have 99 ether already raised. If an investor comes in and tries to raise let's just like 2 ether for an easy example. If an investor comes in and tries to raise 2 ether, this function call is going to revert because we'll have exceeded the hard cap at that point. All right, so let's go ahead and implement this. It's pretty easy. We'll just copy this. Say crowd sale. I'm actually going to paste this in here. Crowd sale emission. So that was emission when we did the minted crowd sale, but here, I'll pull this over. OpenZeppelin Solidity contracts crowd sale validation, capped crowd sale. All right. So I'm going to add a comma here and say capped crowd sale. All right. And we saw that this has some new constructor arguments of the actual cap. So we'll put that here. Let's say capped crowd sale, and we'll pass in the cap. All right. And we'll go ahead and pass the cap here. We'll say uint 256 cap. All right. Let's save that. And now let's try to run this and see what happens. Looks like it's compiling. So we imported everything correctly. All right. So we have a new error on our test. So it compiled correctly, but this is saying Dapp token crowd sale contract constructor expected 4 arguments and only got 3. So we'll go back to our test and add that here. We'll say this.cap. All right, we'll try to run this again. All right, it passes. So we have successfully implemented the cap that we expect on this crowd sale. So now whenever an investor tries to purchase, a certain amount over the limit, then it's going to revert. So I'm not going to necessarily spend time testing that particular bit of behavior because it's tested in this capped crowd sale. But we are going to implement some additional capping, investor capping on our own that I will test. So what I want to do is impose some cap limits individually for an investor. So basically what I want to do is have, a minimum amount that an investor can contribute, and I want to have a maximum amount that an investor can contribute. And I don't want to do this, let's say minimum amount. Sorry, let me update the spaces here. We want to say a minimum amount investor contribution and maximum amount. And I'll just call these the investor caps. So essentially and we want to do this on a total basis, not on a per transaction basis. So let's say we only want an investor to contribute a minimum of 0.002 Ether. And that might be roughly, $1. And we want a maximum to be 50 Ether, right? Because basically we want to contribute a maximum because what if somebody came in and bought all the tokens in the crowd sale? Well, then they'd effectively just control your token. And that would be, not good. And we want a minimum because we don't want, petty contributions to this crowd sale. So, and we want to do it on a total basis, not a per transaction basis. So we have to actually keep track of the total contributions for an investor and check that every time that they contribute. So if they've already contributed 0.002 Ether, they can continue to contribute smaller amounts if they wanted to. So I'm going to just paste some code in here. That's how we'll do this. So this is going to be the investor minimum cap. This is the minimum amount they can contribute, which is going to be 0.002 Ether. And this will be the investor hard cap, which will be 50 Ether. And this is, these values are expressed in way. So, and this is going to be the mapping where we actually keep track of the contributions in the crowd sale. So basically it'll be an address of the investor and their contribution amount so far. And if they've exceeded this, then they'll be fine. If they're less than this, then they'll be fine. But if not, if they're outside either of these, then we want to handle those cases. All right, so let's go ahead and write some code to check against that. So if we looked in this capped crowd sale, we looked at this pre-validate purchase function. That's essentially what we're going to do. They say this contract says if the way raised is, with the new contribution is less than the cap, that's fine. Less than or equal to the cap, then it's fine. If not, we want to revert execution. In a similar way, we want to say, if they've contributed, if the contribution is going to be greater than the minimum cap but less than the maximum cap for an investor, great. If not, stop executing the function. So we can write our own pre-validate purchase function like this. We'll just say, function pre-validate purchase. And we'll pass in the address of the beneficiary. And we'll pass in the weigh amount. All right, and this will also be an internal function. And we'll pass in the logic here, okay? So inside of here, we'll say super, pass the beneficiary, and the weigh amount. So basically, we want to call any other pre-validate purchase commands before this one, and then we'll execute our own logic here. So what I'll do is I'm actually going to get the existing contributions for this investor if there are any. So I'll say, uint 256, existing contribution. And I'll say contributions, which is, this mapping up here that we're using to keep track of this. say contributions, beneficiary. Sorry, I'm going to pull this over so you can see this better. I'm just going to give myself some more space. All right, so existing contributions, the beneficiary, and I'll say UNT 256, new contribution. And this will be the existing contribution plus add way amount. All right. And now is where we want to add this requirement. We'll say require. New contribution is greater than or equal to the investor minimum cap. All right. So this is going to say the new contribution, which will be however much they're spending plus their existing contribution. So if the existing contribution is 0, we just add to this. If it exists, we just also add to it. And if that's greater than the minimum amount that the investor contribute, then that's fine. And we also want to say new contribution is less than or equal to the investor hard cap. So if it's less than or equal to the maximum amount they can contribute, that's also fine. But if either of these conditions fail, then this entire function will stop execution, which is what we want. And it won't allow them to purchase any tokens. So if that's successful, then we'll proceed execution by just updating the contribution amount. So contributions, beneficiary is equal to the new contribution. All right. Take this space out. All right, so let's save that. Let's go ahead and compile this, make sure it runs. If it compiles, we'll write a test. All right, compiled. So now what we want to do is, write some tests for the buying tokens functionality with these caps in place. So I'm going to do that down here. So what we'll do is, just add some space down here. We'll say describe buying tokens, and we'll say function, pass this in, and I'll say describe when the contribution is less than the minimum cap. Let's say function. So I'm going to go ahead and make this one column. Sorry, pass this function and say it, rejects the transaction. Pass this function as well. This will be async because we want to use the async await pattern. All right. And let's say basically const value. Well, first, let's go ahead and define an investor minimum cap so we can pass it into the Crowdsale. Let's do that up here. So let's do it below the Crowdsale configuration. This will be the same value. We'll just copy these values from inside here, but we'll express them in Ether, right? I'll say, this was 0.002 Ether, and that's 50 Ether. So we'll say this investor min cap equals Ether 0.002, and then this investor hard cap is equal to Ether 50, right? Say investor contributions, so caps. And let's also define the constructor arguments. I'm going to just paste those in here. Let's see here. Actually, we don't need any more. So that should be good. All right. So going back to our tests, say const value. for this particular contribution and this particular test is going to be investor min cap -1. So basically take something less than the investor minimum cap, and we're going to try to contribute that to the crowd sale and watch it fail. So we say await this crowd sale buy tokens. So we'll use investor 2 here, and we'll say value is equal to this value that we specified here, and it's be from investor 2. Just remember, it can be we have to specify the beneficiary and also the purchaser if we're using the buy tokens function explicitly. And we'll say should be rejected with, and we can pass in the actual rejection error. So I'm going to go ahead and import another helper that I like to use that I pulled from the OpenZeppelin repository. Actually, let's open the Ether helper. And I'm going to create a new one here. And we'll call this EVM revert. So what I'm going to do is basically just export the revert message that we get from Solidity. And it's going to be used as a helper throughout this test. So I'll go back to the top, and I'll also import this. I'll say import EVM revert. That's going to be our error message that we use. So I'll say should be rejected with EVM revert. So let's try that. Let's run the test, see what happens. All right, so we've got a failure here. Looks like I actually made an error in the smart contract. I was just talking. It's really hard to actually talk and code at the same time, so my apologies. This should be hard cap. Investor hard cap, right. So the new contribution should be greater than the minimum cap and less than the hard cap. So let's try to see if that works. It's a good thing we have tests in place. All right, so we've got, at least the payments work, which is good. All right, so we have another just failure in the test. So investor min cap is not defined. That's just an error, I believe, in our spec. So let's go back and check. Yeah, investor min cap. So this should be this dot investor min cap. Let's run that again. Again, my apologies, but yeah, it's pretty hard to speak and code and think all at the same time. So thanks for bearing with me. All right, so that's good. We got a new error. So this .crowdsale.buy tokens is not a function. So I'm going to capitalize this. All right, so we're getting closer. Should be rejected with. Looks like it says it's not a function. Okay, so I made an error here. Should be rejected with. All right, now it's passing. So it looks like our minimum cap works. So this .crowdsale.buy tokens with a value less than the minimum cap should be rejected with revert message, and it is. So now that you get the idea of how that works, and I took a long time trying to get this pass, I'll kind of speed things up here and just scribble out some tests for the other amounts. So let's do this. The next thing we want to test for is when the investors already met the minimum cap that they can actually purchase. Sorry, buy tokens. So when they've already met the minimum cap, they can basically contribute an additional amount below the minimum cap, which is what we want. So what we'll do is check for that. Sorry. We'll say const value 1 will equal ether 1. And we'll say, that's going to be a value that's like easily over the minimum cap. So we'll go ahead and contribute that amount first. Say contribute first contribution is valid. And we'll say second contribution is less than investor cap, and we want this to be successful. So this value will be just really small, like, one way, but they can contribute as little as they want to, as long as it's a valid amount of Ether. So what we'll do is just say this is valid, and we'll say, this Crowdsale buy tokens investor 1, value 2 from investor 1, should be fulfilled. So we'll just run that. All right, it works. So the next thing we want to do is say when the total contributions exceed the investor hard cap, that it's going to reject the transaction. So basically, if they keep contributing and it eventually sends them over the hard cap, then we don't want them to be able to purchase tokens anymore. So what we'll do is, again, say, the first contribution is in the valid range, right? Just like we did up here. And then now we'll say if the second contribution exceeds the total range, right, then we're going to revert. So they send 2 Ether, right? And now if they try to send 59 or 49, that's going to send them over the cap, which is 50. If that happens, then we're going to revert the transaction. So let's run the test and see what happens. All right, it passes. So the last thing we want to test for is that the contribution is, valid whenever it's in the valid range. So we'll test for that. We'll say, when the contribution is in the valid range, then it should be fulfilled. Let's just do it this way. Sorry. We'll go ahead and say this is going to be the value. Just paste this here and say it exceeds and updates the contribution amount. Oops. All right, so what we want to do is first say, try to buy tokens for some valid amount. Say this.crowdsale buy tokens for investor 2, this value of 2 Ether, which is valid, just like we did here. And we'll say investor 2, and we'll just say it should be fulfilled. So let's test that. All right, that worked. So we also want to check that this public contributions mapping is updated. We can test that like this. We'll say, we'll just get the contribution. And we'll assign it to this variable, get user contribution for investor 2. And we'll say the contribution should be big number equal to this value. Save that, run the test. All right, so it looks like got a little error here. Let's try to address this. So what I'm actually going to do here is instead of using this mapping, explicitly to track the contributions, I don't necessarily want to use this. I'm going to do a new function here. Let's do it just here for now. We'll just paste it here. So this is going to be get user contribution. And essentially this is going to take in the beneficiary and read this contributions amount from the mapping like this. And you can check out this function in the code. So I'll run that again. All right, now it passes. So we can actually get the investor contribution amount with that new function. So while I'm here, I want to do a couple things. I want to show you that you can add, comments. So like if you look at Crowdsale, you've got these comments here, and these params actually get exposed whenever you were going to use this smart contract with something like my Ether wallet or something like that. So these matter. We also have like dev comments and stuff like that, right? These are comments just for developers. But these are params that explain the params, for some program that's hooked up to the smart contract. So we're going to add those to our Crowdsale. So if we get user contribution, I'm going to add a new comment like this. We'll say dev returns the amount contributed so far by a specific user, and param, the beneficiary, will be the address of the contributor, and it will return the user contribution so far. And I'm also going to add the comments for the pre-validate purchase function that we wrote earlier. Let's say this. So dev, it's going to extend the parent behavior by requiring purchase to respect the investor minimum and maximum funding caps. And these are the two parameters, the beneficiary and the weigh amount. All right. So that's all I got for today, guys. That's how you create a capped crowd sale with, minimum and maximum investor contributions. So I hope you like this video. So be sure to subscribe to the channel to see the next video in the playlist whenever it comes out. And until next time, thanks for watching Dapp University.